So here are our review solutions. We've got our little guess method for our problem solving and a little bit of information about graphing motion. You've got a whole bunch of notes on all of that, so look over it as you need to. We're just going to jump right into these problems. So we're going to use the guess method on this, a wide receiver, and we're going to do the thing that we've been doing. We're going to box all of our given information. We're going to circle all of our unknowns. So a wide receiver accelerates uniformly from a velocity of 1.5 meters per second to a velocity of 6 meters per second while running a pass pattern. He accelerates over a distance of 12 meters. What's the acceleration? All right, so for these, I don't have a ton of room, so I have to spread out a little bit. Givens are the initial velocity of 1.5 meters per second, final velocity of 6 meters per second, displacement of 12 meters, and then my unknown is the acceleration. So I want to get an equation that has all four of those things in it. So that's initial velocity, final velocity, delta x, and acceleration. Final velocity squared is equal to initial velocity squared plus 2a delta x. We're going to plug in the numbers that we have. So 6 squared is equal to 1.5 squared plus 2 times the acceleration. We don't have the acceleration. Times delta x of 12 meters. So multiplying all that out, we get 36 is equal to 2.25 plus 24 times the acceleration. We'll write that again up here. 36 is equal to 2.25 plus 24 times the acceleration. We'll subtract 2.25 from both sides. Add all that together on both sides. 36 minus 2.25 is 33.75 is equal to 24 times the acceleration. Divide both sides by 24. And the acceleration, when you put that into your calculator, comes out to be 1.4 meters per second squared. All right. The next one is going to ask two parts, and it's really nice. So, truck driver speeding down the highway slows from 35 meters per second to 15 meters per second in 4 seconds. The first one wants to know the acceleration of the truck. So for this, my givens, that my initial velocity is 35 meters per second. My final velocity is 15 meters per second. My time is 4 seconds. My unknown right now is the acceleration, so I want an equation that has all this in there. Well, that's so we're going to pick the equation final velocity is equal to initial velocity plus acceleration times time. So my final velocity is 15, my initial velocity is 35, plus the acceleration, which we don't know, times the time of 4 seconds. So we're going to subtract 35 from both sides. That goes away over here, and what that gives me is negative 20 is equal to 4 times the acceleration. Divide each side by 4. Goes away over here. So the acceleration comes out to be negative 5 meters per second squared. How far does the truck travel during this time interval? Well, that makes my other unknown delta x, but I've got everything, so I'm going to pick the easiest equation for me to plug things into. The easiest equation for me to plug things into is delta x is equal to v initial times time plus 1/2 acceleration times time squared. And we can just plug numbers straight into that. There's no algebra that we have to do, so it's the initial velocity 35 times the time of 4 seconds plus 1/2 times the acceleration of -5 times the time of 4 seconds squared comes out to be 100 meters because we're solving for delta x. Number 3, car moving with constant velocity to the right slows down from a velocity of 15 meters per second to a velocity of 5 meters per second in 5 seconds. What's the acceleration of the car? So my givens are that the initial velocity is 15 meters per second. The final velocity is 5 meters per second. The time is 5 seconds. And what we want to find is the acceleration. So we're going to pick an equation that has all of those things in it. Our equation is v final is equal to v initial plus acceleration times time. Plugging in our numbers, we get 5 is equal to 15 plus acceleration, which we don't know, times the time of 5. So that gives me -10 is equal to 5a. We're going to divide both sides by 5. Those go away. And so our acceleration comes out to be -2 meters per second squared. It's going to be important for you all to do units on your test. All right. Oh, one snuck in. A rock is thrown straight upwards with an initial velocity of 20 meters per second. How long does it take the rock to return to the ground? All right. So our initial velocity is 20. It's going to return to the ground. This is a little advanced. If you can follow with it, great. If not, fine. So returning to the ground means that my delta x is equal to 0. I come back to where I started. And then my acceleration for this whole thing is going to be 10 meters per second squared down. That's because it's in free fall. So that's the one piece of information you don't really have. Everything else you can kind of figure out. So for number 4, I'm given the initial velocity is 20 meters per second. Negative 10 meters per second squared. I'm given that the delta x is equal to 0. I'm given that the acceleration is -10 meters per second squared. My unknown is how long it takes. And again, if you don't feel like doing number 4, this one is optional. That's from the next unit, so we're going to let that go. I'll go ahead and solve it. So we want the time, and we want the equation that has all these things in it. Well, that equation is delta x is equal to v initial times time plus 1/2 at squared. If we plug in all of our numbers, we get 0 is equal to 20t plus 1/2 times -10 times t squared. So I get 0 is equal to 20t minus 5t squared. I don't know what's going on, but I think it's going to be easier to see if I move that 5t squared over. So I'm going to add 5t squared to both sides. Crosses out over here, and I get 5t squared is equal to 20t. What I notice is that I have a t on both sides. So if I divide each side by t, both of these t's cross out, and one of these t's cross out. So that tells me 5t is equal to 20. Divide both sides by 5, and t comes out to be 4 seconds. Again, we're not there yet. So if you want to, this one's great to skip. The other ones are not great to skip. We need to do the other ones. So questions 5 through 10, use the following graphs as answer choices. Each question may have more than one correct answer. Which graph shows an object that has positive acceleration? So, for positive acceleration, on x versus time, we should see some sort of smiley face. On velocity versus time, we should see a straight line with positive slope. Both of those things mean positive acceleration. So that's really good to associate in your mind. Positive acceleration is concave upslope on position versus time, and a positive slope on velocity versus time. So if we look for that, for positive acceleration, since these are all position versus time, I want something that's concave up. E is concave up. That's definitely a smiley face. And F is concave up. That's a smiley face. So E and F are both positive acceleration. For the acceleration equals to 0 on x versus time, what that means is we're going to have a straight line. So this way, or this way. Acceleration equals 0 means constant velocity. And what constant velocity means for position versus time is that slope of position versus time is constant. That's a straight line. So anything that has a straight line is going to have 0 acceleration. That's A and C. So for this one, A and C show 0 acceleration. Which graph shows an object that is slowing to a stop and then remaining at rest? So, for the second half, remaining at rest, that tells me the velocity is 0. So the slope of position versus time is equal to 0. That's a flat line. So the end of it's going to be a flat line. And then if we are slowing to a stop, basically what that means is velocity the velocity gets closer to 0. So the slope of x versus t gets closer to 0. That's happening right here in graph D. I have a nice horizontal line at the end, and my velocity starts off, my slope starts off positive, and then ends up getting closer to 0. So number 7, the answer to that is D. Which graph shows an object with negative initial velocity? Negative v0 means we have a negative initial slope. So the slope to begin with has to be negative. So for number 8, let's go through these. A, the slope to begin with, that is a negative initial slope, initial velocity. Here, the initial slope is 0. Here, it starts off positive. Here, the slope starts off positive. Here, ooh, that's a negative slope, so that's a negative initial velocity. And here, that slope's positive. So the only ones with negative initial velocity are A and E. Which graph shows an object with constant positive velocity? Well, what that means on x versus time is constant positive slope. A line that looks like that. So looking at our choices, the graph with constant positive slope is graph C. And then which graph shows an object that changes directions? So changing directions, we move in one direction and then we move in another. So for the things that we have seen with that, that's changing direction on position versus time, because we were going up and then here we turned around and we went back down. Or this one, for that one we are moving down. Here we're going to turn around and move back up. So which one looks like one of those shapes? The only one we have is graph E. (10 through 12). Use this. An object starts from rest and accelerates uniformly in a straight line in the positive direction. So we start from rest. After 11 seconds, the speed is 70. Then 10 is determine the acceleration. So, for my givens, the initial velocity is 0. We start at rest. Our final velocity is 70 meters per second. The time is 11 seconds. And for this first question, the unknown is acceleration. So I want to pick an equation that has all of those things in it. So we got v final equals v initial plus acceleration times time. We're going to plug in our numbers. 70 is equal to 0 plus acceleration times 11. So kind of to rewrite that in a cleaned up way over here, just kind of go this way with it. 70 equals 11 times the acceleration. We'll divide both sides by 11, and then with our calculators, we see that the acceleration comes out to be 6.4 meters per second squared. Here's the deal with these kinds of multiple choice questions. If it's asking you to solve a problem, you still need to use the guess method. How far does it travel during the first 11 seconds? So now I also want delta x. So for delta x, the easiest thing to do is to go, all right, v initial times time plus 1/2 acceleration times time squared. Plug in everything we know. 0 times 11 plus 1/2 times the acceleration of 6.4 meters per second times 11 seconds squared. This thing's 0, and we can put the rest of that in our calculator. And our delta x comes out to be 387.2 meters, which kind of rounds up to 390. Last one, what is the average velocity during the first 11 seconds? So we could do this two different ways. Strike that. We'll just do this one way. Average velocity is always total displacement over total time. We have our total displacement, 390 meters, and our total time of 11 seconds. So our average velocity comes out to be 35-ish meters per second. A car accelerates, I'm starting a different color, from rest to 25 meters per second over a distance of 100 meters. How long, how many seconds does it take to do so? So our givens are that the initial velocity is 0, the final velocity is 25 meters per second, the displacement is 100 meters, and ultimately we want to know what the time is. We have a big problem here. That big problem is we don't know what the acceleration is. So step 1 is to find the acceleration. I want the equation that has initial velocity, final velocity, displacement, and acceleration in it. So final velocity squared is equal to initial velocity squared plus 2a delta x. Plugging in our numbers, 25 squared is equal to 0 squared plus 2 times the acceleration we don't know times 100. So 625 is equal to 200 times the acceleration. We're going to take and divide both sides by 200. And when we do that, the acceleration comes out to be 3.125 seconds. That's just the acceleration. That's another piece of known information. Now we're ready for the second part of this. Find the time. Once we have everything, finding the time, question 2 is usually easiest with this equation. V final is equal to V initial plus acceleration times time. 25 is equal to 0 plus 3.125 times the time. Clean that up a little bit. 25 is equal to 3.125 times the time. Divide both sides by 3.125. And that time comes out to be 8 seconds. Number 14, a kid on a bicycle going 10 meters per second hits the brakes and skids to a stop in 2 seconds because he wants to miss a dog. How far does he travel before he stops? So for this one, my givens are that we have an initial velocity of 10 meters per second, a final velocity of 0 meters per second, a time of 2 seconds, and our unknowns. Ultimately, we want to know how far does the kid travel. But before we can do that, we've got a problem. We need to get the acceleration. So first step is to use the equation that has all 4 of those things in it to find the acceleration. So for that part 1, finding the acceleration, we have V final is equal to V initial plus acceleration times time. So we're going to plug in our numbers. 0 is equal to 10 plus acceleration times 2. I'm going to subtract 10 from both sides, minus 10, minus 10. So that goes away. I've got negative 10 is equal to 2a. Divide both sides by 2. That goes away. And my acceleration is negative 5 meters per second squared. But that's just, what is that? That's just another piece of known information. What I want now is to know how far he goes before he stops. Since I have everything else, the easiest way to find delta x is to do delta x equals v initial times time plus 1/2 acceleration times time squared. So plugging in our numbers, delta x is equal to 0 times the time of 2 seconds plus 1/2 times the acceleration of negative 5. I'm sorry, I made a mistake. Delta x is equal to my initial velocity of 10 meters per second times 2 seconds plus 1/2 times the acceleration of negative 5 times 2 squared. So delta x is equal to 20 plus 1/2 times negative 5 times 2 squared, negative 10. So my delta x comes out to be 10 meters. Last one, a runner accelerates from rest to a maximum speed of 15 meters per second in 1.8 seconds. What's her acceleration? So the initial velocity is 0. The final velocity is 15 meters per second. And the time is 1.8 seconds, and we want the acceleration. So the equation that has all 4 of those things in it is final velocity equals initial velocity plus acceleration times time. So 15 is equal to 0 plus acceleration, which we don't know, times the time of 1.8. So So cleaning that up, 15 is equal to 1.8 times the acceleration. We're going to divide both sides by 1.8. Crosses out, and our acceleration comes out to be 8.33 meters per second.